Here's a real quick introduction to linear inequalities in two variables. Suppose we wanted to plot a picture of the inequality y greater than or equal to x. Well, what does that even mean? Well, it means that we want the set, want to plot the set of pairs x, y with y greater than or equal to x. Okay, so it's going to be some set of points in the plane. So yeah, a pair is just a point in the plane. So we want to look at all the set of pairs with y greater than or equal to x. In other words, the height greater than or equal to the horizontal coordinate, the vertical coordinate greater than or equal to the horizontal coordinate. Well, as with inequalities you've seen before, usually the key is to analyze the equality first. And that's just y equals x. We know how to deal with that. That's a line. And if these guys are both linear in x and y, this will be a linear equation in x and y, and you'll be able to figure out that's a line. Okay. I picked a really simple one, y equals x. And so let's just plot that in 2 dimensions. It's just that line. Okay. So let's make that a lot smaller. So there's a tiny little version of that. All right. So what about the whole inequality? Well, when we've got the equality, that should be exactly the boundary of the region where this is true. There's going to be lots and lots of points where y is greater than or equal to x. Anything where it's really high and not very far over to the right. And the boundary of that, where this ceases to be true, is going to be exactly where they're equal. So for example, if I start out here, 2 comma 4, y is 4, definitely bigger than 2. 2 comma 3, still true. 2 comma 2, it's just barely true. And then 2 comma 1 is not true anymore. Or 3 comma 2 is not true anymore. X is 3, y is 2. So what's going on is that this is the boundary, and then it's either everything on one side or the other. Real easy. And because it's y greater than or equal to x, y is the bigger one. That's why it's going to be this region up here. The other way to do that is just test any one point. Just say, okay, I know this is the boundary. It's either everything up here or everything down here. Just test something random, like 0, 1, for example. Okay, 1 is the y coordinate, 0 is the x, 1 is certainly greater than or equal to x, and so that's going to work. So it's going to be in here. And then that means that it's all of this region. Okay, so I'll just summarize that. 2 strategies for figuring out which side of the boundary line. And we're going to shade that in. One is, sometimes you can do it by just thinking about, well, think about the geometric meaning of the quantities. That works for when this is just simple, y greater than or equal to x. It means height is bigger than x. So anything that's really high and not far to the right is going to be here. So like all this stuff, it's really high and definitely not very far to the right at all. This guy is not high and far to the right, so it's not going to be shaded over here. Okay. Sometimes that works. Sometimes it's a little too complicated if these guys get more complicated. And another way that always works is just test any one point on one side. E.g., in this case, the point 1, 0 or 0, 1 satisfies the inequality. And so we're going to shade in the top side. And so in fact, this computer program actually will do that for us. And so here's the result. Compute, plot, inequality. And it doesn't give an amazingly good result, but there it is. Okay. So let's just do one more quick example. I don't want to do too much on it because this is just a brief intro. But let's say we had y is less than or equal, or less than, to bring out something a little bit different, 2x minus 4. Okay. Well, first let's plot y equals 2x minus 4. So we're going to have to review how to plot lines, certainly. Oh, actually, it's going to work better if I just plot that. Okay. Intercept minus 4, slope equal to 2. Now the scale doesn't look like slope 2, but that's because they chose the scale to be different in both the axes. Okay. And now y less than. Now one thing that's different here is that technically the line here was included because y equals x was legal. Here, what we'd usually do is we'd put this in dotted because y equals 2x minus 4 is not legal. We'll talk about that more. And here, it's y is smaller than it would be if it were on the line. So again, it's going to be possible to just look at the meaning here. It's going to be everything below. Or another way to test it is just pick anything either above or below. Just pick the origin, for example. That's always easy. As long as it's not on the line, it's a good test point. Let's test that. Is it true that 0 is less than minus 4 if you plug in 0 and 0? No, it's not true. So here the answer is false. And so here it's going to be shaded in here. So let's try getting it to plot. And there it is. Okay. There's the region. Okay. Just let me say one pitfall. With this testing strategy, here's what I see happen. You got this line, and then you test, like, say, the origin, and you test it, and your subconscious often assumes that because you picked that point to test, the answer should be yes. And so there's going to be a bias towards the answer yes. But the answer was no. If you plug in 0 for y and 0 for x, you're asking, is it a true fact that 0 is less than minus 4? No, it's not true. So it's not this region, it's everything else. So watch out for that pitfall.